Okay, let's continue on with the show. So you've done this. There are a few more examples here. For example, this is a block which is suspended by a few cables. This is cables. You've got pulleys. This is also pulleys. So when you have pulleys, you gotta cut it. Cut the pulleys. Cut the pulleys. So since your pulley is actually continuous, the cable here is continuous, so tension is continuous. Wherever you are on the cable, it is the value T. Wherever you are on the cable is the value T. Let's draw properly. So wherever you cut it, this will be T. This will be T. This will be T. So that's why if you isolate this block, you're gonna get 2T. If you look at block B, it's only 1T lah. So this one you can study on your own. I'm going to be doing a slightly more similar example to this later. This one, okay, let's do the slightly more, let's do this one. This is similar, almost similar to this problem. Almost similar to this problem. So exercise 4 and exercise 7 is almost similar. So let's do this one. Okay. Let's read and understand. When the blocks are released, determine their acceleration and the tension of the cable. Neglect the mass of the pulley. So look at this problem. This is 30 kilo. So this is heavy. This is 10 kilo. This is lighter. So when the blocks are released, definitely 30 kilo will go down. Why? Because it's very heavy. If 30 kilo goes down, block A will go up. So you have block B and you have block A. So you have two blocks, which means you have two bodies. So when you analyze, you need to analyze separately. When you do free body diagram for A, the acceleration is upwards, positive. And when you do free body diagram for B, acceleration downward will be positive. So that is the thing that we need to do. So number one, as you can see here, these are cables, and these cables are connected to each other. So since they are connected to each other, there is something called, what was the term? The term is dependent motion. Motion yang bergantungan dengan each other. So if B goes down berapa, A naik atas berapa. So this has been reviewed in the previous chapter lah, something called dependent motion. So when you are doing dependent motion, you need to, number one, establish datum, and then you need to get the length of the cable, and number three, differentiate over time. So these are the 3 steps you should do when you look at something with dependent motion. So now let's do all that. I'm gonna clear all the things. Screen, cannot erase all ink on the slide. Okay. So number 1, this is dependent motion. You need to establish the datum. So this is a datum. So the length of the cables, it varies. How does it vary? This is something we call SA. This is something we call SB. So the length of the cable is what this cable, and then it goes up. So length of the cable is equal to SA campur SA. Why? 2 cables. 2 SA. And plus this one. This whole cable going down plus SB. This one is equal to the length. Of course, you have all these things, right? And all these things. But this 1 thing and 2 thing here, when you differentiate, the length is similar at any time, so it becomes 0 lah when you differentiate. So you have 2 SA plus SB is equal to L. So you differentiate over time, dL over dt dapat 2 VA campur VB. dL over dt equals 0 lah. Sebab length ni tak berubah. Length is the same. So you have 2VA plus VB. Or 2VA is equal to negative VB. Kalau differentiate one more time, kita akan dapat 2AA equals negative AB. So this is the relationship. This is the relationship. So negative is nothing. Is just opposite motion. So which means one is going down, the other one is going up. That is just what it means. So you might as well get the ratio as 2AA is equal to AB. This is the ratio. This negative value we just have to eliminate. So this is how you solve and get the relationship between the 2 blocks, which is block B and block A. So dependent motion, so let's write it down. 2AA is equal to AB. This is the relationship for this dependent motion. Okay, so I hope you all have copied this one, because we're gonna complete with the task of settling everything. So everybody have copied in their slides, and I'm going to clear all slides. Eraser, erase everything, because we are solving the equation of motion. We are going to be solving the equation of motion. So dependent motion is very easy to look at. If you don't even look at and derive properly, you can even look at this already. Look at here. Ini ada 2 kabel kan? 1, 2. So 2 kabel. So 2AA sama dengan AB. AA is slower. ini faster. Sebab tu dia kena ada 2 AA baru sama dengan AB. So bukan 2 AA ni, 2 ni lagi besar tak? 2 AA meaning dia lagi slow. Okay, baru dia sama dengan AB. Dia kena kali 2, diperlukan bantuan. Alright. So the relationship has been established. So now we need to do a free body diagram. So when you do a free body diagram and you see things like cables, so you have to cut them up. When you cut them up, you will see that the location where you have cut them up, that location will be tension, tension, and tension. So now, we need to isolate the bodies. So let's isolate the first body, which is body A. So now let's draw. Draw the body A. The body A is slightly up, slightly up like that. So the tension on body A is actually here 2T. Sebab dia ada 2 kabel sini. 2T. Going down is mg, or rather mag. You get what I mean, right? Ini blok ni 10 kilo. Payahlah tulis macam ni mg aje lah. Ini 10 kilo. So this block will go up. Why? 30 kilo is heavy, right? So 30 kilo going down. So atas is actually the acceleration direction, and atas is positive. So this is free body diagram for block A. Next, we draw free body diagram for block B. So block B is over here. It is heavier. Berapa heavy? 30 kilo. Now, draw the cables. Only one, T. Going down, mg. Since the block is going to travel down, the block is actually traveling down. A is positive on the downside. So this is free body diagram for block B. So now we have actually isolated the 2 bodies. They are isolated or free. Okay, so now we have to solve free body diagram for each of them. So now let's do it. Might as well start with body A. Body A. Okay. So we're gonna be solving summation Fy lah, because everything is traveling in the y direction. Summation Fy is equal to MAY. Going up is positive for body A. This is body B, Okay, so now you don't have to look at the original picture. This is the original picture, right? This is original. No need to look at this anymore. Look at your free body diagram. Look at this one. This only. So naik atas is positive. So dapat 2T. Turun bawah is negative. Minus mg equals MA. Okay? So simplify. 2T minus 10 kali 9.81 sama dengan 10 kali AA lah actually, because you are looking at block A. So if we simplify a bit, dia jadi 2T tolak 10 AA equals 98.1 lah, 98.1. So look at this one. So this is actually important equation. So this is equation number 1. Now, finally, look at body B. Body B. This was body A. Now look at body B. So this is very important. Summation Fy sama dengan MAY. So going down is positive. So this is dynamics. We solve the acceleration punya direction is positive. So going down positive, going down positive. Ini susah sikit ah. You got to wrap around your brain that going down is positive. Mg going down minus T. T sudah jadi negatif. Mg minus T equals MAB. So M ni is actually MB lah. Yang atas ni adalah MA. So let's plug it in. Ini pun MB. Ini pun MA lah. Make sure you are doing it correctly. So MB is actually 30 times 9.81 tolak T sama dengan 30 also AB. So this equation becomes, T ni bawa ke sana lah. So you're gonna get 30 AB campur T sama dengan 294.3. Okay, so that's it lah. This is equation number 2. So now let's count. Berapa unknown? You have 1 unknown. You have 2 unknown. You have 3 unknowns. So if you have 3 unknowns and you have only 2 equations, you cannot solve it. You have to simplify it a bit. So in order to simplify it, you can use this equation, this relationship. Relationshipnya adalah AB sama dengan 2AA. So plug in this one lah. Where is our AB? This is our AB. So simplify this equation to become 30 kali dengan AB. AB sama dengan apa? 2AA campur T sama dengan 294.3. Now you can solve it. Ini sudah jadi T campur 60 AA equals 294.3. So if you solve this equation, then you solve everything lah. Which one to solve? This one and this one. How to solve? Use calculator. Ya, plug it in. Apa dia? Macam ni lah. A, B, C. Ini equal C. So, T dulu kan. Kena make sure betul lah. T depan, T depan. A depan, A depan. So, ini 2. Ini negatif 10. Ini 9.81. No. 98.1. Ini pula 1. Because T, right? This one is already 60. Ini 294.3. So if you solve this, you're gonna get X sama dengan apa? Sama dengan T. Y sama dengan AA. This is the thing lah that you get. So solve using your calculator. 5 for equation. 2 negative 10 98.1 160 294.3. So dapat jawapan 67.9. 67.9 ni apa? Newton. Acceleration is 3.77 meter per second squared. So, since dapat this one, right? You got the answer. AA ke AB? AA. AA sama dengan 3.77 meter per second squared. So AB sama dengan 2AA. So AB sama dengan 2 kali 3.77. Apa jawapan? 2 kali 2 kali 3.77. Dapat 7.54 meter per second squared. Tension pun dapat. Berapa tension? 67.9 Newton. Acceleration going down. Ini AB lah kan? Ini adalah AB. Ini adalah AA. Acceleration going down 7.54. Acceleration going up is 3.77. Okay, done. Bukan salah, ha? It's actually betul. Okay, we're done. This keep. Okay, next. So next exercise that we're going to do is again 2 objects. One body, another body. 2 bodies. Difference is one is going down, the other one is going to the right. So B is very heavy or not. B is 25 kilo. I think 25 kilo will win in this case, because frictional resistance is not so much. 25 kilogram going down, I think it's much higher. So 25 kilo will go down, block A will go to the right. And you have something called, again, you have dependent motion. Due to everything is connected using one single cable. So 2 blocks. So remember, you have to cut your cables and apply equilibrium, and wherever you cut, you're going to get tension, 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 right, at the location of your cuts, at these 3 locations. Okay, so let's read properly. 2 blocks originally at rest, neglecting the mass of the pulley and effect of friction on the pulleys. Okay, assuming that coefficient of friction between block A and the horizontal surface is 0.25, this one, mu K is equivalent to 0.2. Ini, you use this for static. If this is moving, use this one. Do not use static anymore. Determine the acceleration of each block and the tension of the cable. So obviously, block B, no friction. Yang ada friction ini je, block A je. Only block A has friction. Okay, so everything is good. Every explanation has been done. Now we're going to do it. So again, number 1, dependent motion. So you need to find some sort of datum. So this is your datum, this is your SA. This one, I think you can take this one as datum. This is SB. So total length is SA plus 3SB. When you differentiate, you're going to get V. Okay. When you differentiate dl over dt, you're going to get 0 lah for this one. So you're going to get VA plus 3VB. Differentiate one more time, you're going to get, so once you differentiate this one actually turns to 0. Okay, turns to 0. Why? Because the length does not change. So this one becomes 0. Differentiate again, also becomes 0 lah. So this one is going to be AA plus 3AB. So the relationship is AA is equal to negative 3AB, but again, negative is just showing different direction. So the relationship is AA is equivalent to 3AB. So which one is slower, which one is faster, you know already. AB is slower by 3 times. 3 times slower due to this. Okay, so this is done. Keep it, I guess. Okay, never mind lah. Maybe we have space. So next thing that we should do, okay, this is the relationship. AA is equivalent to 3AB. This is the dependent motion. Next thing that we should do is, I think we need to clear this thing up. Clear this thing up. Oh, I cannot already. Never mind, maybe you have time, maybe you have space. You cannot clear. Okay, next thing is free body diagram. Free body diagram, you have to look at A. A is actually going down. Okay, so you've got mg you've got normal, and you also have friction. And for this one, you even have tension. Right, remember, this one when you cut it up, you have tension, tension, tension. So T, T, T. This one goes down, this is mg. So motion, this thing will go to the right, so this is positive. This is acceleration in the positive sense. This thing goes down, so acceleration is positive going down. So free body diagram. For block A, okay, I'm gonna draw it different color. This is block A. This is block B. Block A is actually 30 kilogram. 30 kg. Block B, 25 kg. So let's put it back. mg. Normal. Frictional forces will always opposing the motion. This one is equal to mu k times normal A. And then you have tension T. So moving on to block B, you have 3T, 3 tension. Going down, it's actually mg. So one thing we need to note of, A is positive on the right hand side. A is positive going down, down, down. Yeah, pretty much. We have isolated the bodies. This is the first body that we need to analyze with its own free body diagram. And this is the second body that we need to analyze with its own free body diagram. So this one is F, B, D. Anything else? Nothing else. So now we can write our equation of motions. So this is the divisive line. This is the divisive line. Okay, so next, summation fx. Oh, what are we doing right now? We are doing for body A, block A. Summation fx is equal to max. Which body are we doing? We are doing for MA. AX pun adalah yang A punya lah. Alright. Okay, this is the equation. To the right is positive. So you don't have to look at this one anymore, okay? Don't look at this one. Look at your free body diagram only. Look here. Look here. Avoid any confusion. To the right is positive, so T minus mu k times normal A is equal to MAAX. AX ataupun AA lah, senang. Okay, so elaborate. Use mu k, which is 0.2. 0.2 times normal A is equal to, berat dia adalah 30 kilo kali dengan AA. Anything else that we can expand here? Nothing much. This is it, I suppose. This is one of the equations that you need to take care. Now we're going to look at block B. B block. This one was A block. So B block, summation F y is equal to M AY. So going down is positive. What else? So look at this one. So we only look here. Here only. You don't need to look at original photo anymore. Look at your free body diagram. So 3T is already a negative. Mg has become a positive. So Mg minus 3T is equal to MB AB actually. This one is MB. Mg, the weight is 25 kilo. 9.81 minus 3T. So this is 25. However, in order to reduce number of unknowns, we need to replace lah. AB sama dengan berapa. So from this equation, which we have derived using dependent motion just now, we know that AB sama dengan maybe simpler kalau kita tukar jadi tukar AA je lah. So never mind. So AB we maintain. AB is maintained. Y you will replace later. 25 times 9.81. 245.3. 245.3 minus 3T equals to 25 AB. Oh, replace even better. Replace lah. So let's replace. Actually, AB is equivalent to 1/3 AA. From here, AB is equal to AA divided by 3. Okay, let's replace. AB is equal to AA divided by 3. Can you replace this thing here? So if you replace, you're going to see AA divided by 3. Your now equations become 25 bahagi 3. 8.33, so no choice lah. This one becomes 8.33 AA minus 3T 245.3. I think we have to rearrange this equation, make it slightly better. T dekat depan, so T has to be in front lah. So this equation, if I were to rearrange to make it better, you're gonna see make it a positive lah 3T ni. 3T bring there, so plus 3T plus 58.33, AA equals 245.3. Yeah. This is good. This equation is a proper one. So which equation that you need to solve? These two equations. Which is it? This one lah. You need to solve this one, and you need to solve this one and this one together. Simultaneous equation. So this one I need to rearrange already also. So I guess the proper equation that you need to rearrange is, okay, let's write it properly. T dekat depan. T N A. NA tak dapat How much is your NA? NA senang aja actually. NA is equal to mg. Yeah, this one. This one we can simplify a bit more. This one, if you solve block A punya summation Fy, block A kan, block A, look at block A. It's like that. You have normal and you have mg. So this is normal. So kalau solve summation Fy, dia akan jadi summation Fy equals 0 lah. You're gonna get normal minus mg equals 0. So normal is equivalent. Okay, so you get the point lah. Normal is equivalent to mg, which is equal to, berat dia 30 kali 9.81. Berapa? 294.3. Otherwise you cannot solve so many unknowns. So this equation we gotta plug in mg, tapi mass yang A lah. So if we plug that in, this equation becomes T tolak 0.2 kali 30 kali 9.81 equals 30 AA. So rearrange back, T letak depan, tolak 30 AA equals, negatif buat sana kan, you're gonna get a positive 30 by 9.81 times 0.2, 58.9. This is final, and this equation is simple. So you don't need to solve these two. Actually you need to solve these two lah, but these two has been, so you gotta look at the links lah. This one has gone here, so you gotta solve these two lah, these two equations. Again, use calculator. Okay, so let's solve it using calculator in this small space here. So you're gonna see something like this. This one will be A, this one will be B, this one will be C. Put down all the values that we need. A sama dengan 1 negative 30 58.9. A yang bawah akan jadi 3 8.33 245.3. So key in your calculator. X will be equivalent to T, Y will be equivalent to AA. So punch in your calculator. Yeah, so you got the answer. This one will be 79.8 Newton. Acceleration will be 0.697 meter per second squared. So since you have AA, AB sama dengan this one lah. So look at this one. AA bahagi 3, so 0.697 divided by 3, you're gonna get 0.697 bahagi 3, 0.232 meter per second negative 2. Okay, so this is the final answer for tension of the cable. Block A moves to the right 0.697. Block B slightly slower, going down 3 times slower than block A at 0.232. So done. This is exercise 11. There are plenty more exercises that we can do. So next one is, let's do this one. This is exercise 8.